Imagine this, you're sitting at home enjoying a quiet Sunday evening and suddenly you start getting calls from unknown numbers, weird emails, or even mail from companies that you've never heard of. It's annoying, right? Well, let's take it up a notch. What if your personal information was out there for anyone to find? Scary stuff, but that's the reality of the world we live in. But enter the picture Incogni, the superhero of our digital age. Incogni is here to save the day by protecting your personal data. They fight the good fight against data brokers who collect and sell your information without you even knowing. These brokers have everything: your name, address, phone number, even possibly your social security number. So how does Incogni tackle this massive issue? Well, it's simple. They reach out to these data brokers on your behalf and request the removal of your personal data. Plus, they keep doing this over and over to ensure your information stays off the market. Now let's talk real life impact. Imagine you're an influencer and suddenly you realize that someone's using your data for nefarious purposes, or think about a friend who's had their identity stolen, resulting in huge fraudulent loans in their name. These aren't just horror stories. They happen more often than you think. Incogni steps in to make sure that doesn't happen to you. All you have to do is create an account, tell them whose data to remove, grant permission, and sit back, relax while they do all of the work. You can try it out risk-free for 30 days, and if you're not satisfied, get your money back, no strings attached. So head over to incogni.com/foundout and use the code FOUNDOUT to get 60% off an annual plan. And now today's episode. Quick, are you right brains or left brain? Chances are you answer this question immediately and definitively. If you are the creative, intuitive side drawn to creating music, stories, images, and other forms of art, then you are right brains. If by contrast you are more analytical and logically drawn to mathematics and pattern recognition, then you are left brains. And if you don't already know which you are, then there is a whole industry dedicated to help you finding out, offering countless online quizzes, seminars, and other materials to help you pinpoint, strengthen, and get the most out of your inherent cognitive strengths. Indeed, left/right brain theory has found its way into all sorts of disciplines, particularly the world of business, where many companies hire right-brained employees for more creative roles and left-brained employees for managerial positions. Given its widespread acceptance and use, this theory must be based on the latest neuroscience. Well, sorry, no. Like the notion that we use only 10% of our brains, the idea that our skills and personality are determined by which hemisphere of our brain is most dominant is a persistent pop psychology myth, one which, like most personality tests, including the popular Myers-Briggs, has about as much predictive power as astrology. Yet, like many modern scientific myths, the left-right dichotomy is based on a kernel of truth. Certain brain functions are indeed concentrated in different hemispheres, but the way this lateralization works is far more subtle and complex than the simplistic model presented in pop psychology. So, exactly how much of the modern myth is true and how much is complete fiction? Well, let's find out as we dive into the fascinating science of the divided brain. From the outside, the brain appears perfectly symmetrical. At the bottom is the hindbrain, composed of two structures: the brainstem, which controls autonomous functions like breathing and digestion, and the limbic system, which controls more complex but basic functions like memory, processing, emotion, and motivation. Below the hindbrain is the cerebellum, which handles sensory processing and motor coordination, while wrapped around it is the forebrain or cerebrum, which is responsible for higher cognitive functions. The cerebrum is divided down the middle into two hemispheres, which are further divided into four lobes: frontal, parietal, temporal, and occipital. The cerebellum is divided into two symmetrical hemispheres, while the cerebral hemispheres are connected via a bundle of nerve fibers known as the corpus callosum. In the 1860s, however, evidence began to emerge that the brain is not as symmetrical as it outwardly appears. In 1861, French physician and anatomist Paul Broca encountered two patients with striking verbal impairments. The first, Louis Victor Le Borgne, had almost completely lost the ability to speak, only being able to pronounce a single word: temps, the French word for time. Strangely, his other cognitive faculties, including his ability to read, write, and understand spoken language, were impaired. The second patient, Lazare Lelong, suffered a similar impairment and could only pronounce 5 words: yes, no, 3, always, and Lilo, a mispronunciation of his own surname. Following these patients' deaths, Broca autopsied their brains and discovered that both had been suffering from neurosyphilis, which had inflicted lesions in the exact same area of their brains, the third convolution of the frontal lobe of the left hemisphere. Based on these and 12 similar historic cases, in 1865, Broca published a landmark paper titled Localization of Speech in the Third Left Frontal Cultivation, in which he theorized that speech production was centralized in this location, now known as Broca's area. A decade later, Later, in 1874, German physician and anatomist Karl Wernicke described a similar but distinct kind of aphasia in which patients were able to pronounce words fluidly but spoke in incoherent sentences devoid of structure and meaning, what is commonly today called word salad. Strangely, these sentences retained the cadence and syntax of ordinary speech, while the patients remained completely unaware that their speech was in any way disordered. Their ability to understand language, both spoken and written, was also often impaired. Like Broca, Wernicke discovered that this impairment was caused by damage to a very specific area of the brain, in this case a region in the left posterior frontal lobe, now known as Wernicke's area. These observations led Wernicke to divide aphasia into two basic types: Broca's, or motor aphasia, and Wernicke's, or sensory aphasia, also known as receptive aphasia. Broca and Wernicke's discoveries led psychologists to conclude that language production and comprehension are localized entirely in the left hemisphere of the brain. However, it was not until the 1960s that the full extent of lateral specialization in the brain truly started to be appreciated. At the start of the decade, neurosurgeons began performing a radical new procedure to help sufferers of severe epilepsy. Known as a corpus callosotomy, the procedure involved severing the nerve fibers of the corpus callosum to prevent epileptic signals spreading from one hemisphere to the other. Initially, the surgery was believed to have no side effects, but the longer patients were observed, the stranger their behavior became. They began favoring the right side of their bodies when performing everyday tasks and seemed completely unaware of any stimulation coming from their left side. For example, if they bumped their left arm, they would not notice, and if an object was placed in their left hand, they would deny its existence. Intrigued by this strange behavior, in 1962, psychologists Roger Sperry and his graduate student Michael Gazzaniga of the California Institute of Technology began a series of groundbreaking experiments to find out just what was going on inside the split brain patients' heads. What they discovered would change our understanding of the human brain forever. While the corpus callosum had previously been considered a largely functionless structure, with psychologist Carl Lashley even speculating that it served no greater purpose than to keep the hemispheres from sagging, Sperry and Gazzaniga, though, quickly discovered how vital a role it plays in the functioning of the brain. Due to a quirk of vertebrate evolution, our nervous systems are contralateral, meaning that each hemisphere receives information largely from the opposite side of the body. For example, the optic nerves, which convey visual information from our eyes to our occipital lobes, cross over at a junction called the optic chasm, meaning that information from the right eye is transmitted to the left hemisphere and vice versa. Similarly, each hemisphere controls the opposite side of the body, such that a stroke in the left hemisphere will produce paralysis on the right side of the body and vice versa. Now, ordinarily, this counterintuitive arrangement works just fine, as the information is immediately transmitted to the correct hemisphere via the corpus callosum. But in split brain patients, this channel of communication no longer exists, meaning that information transmitted to a particular hemisphere stays in that hemisphere. And this is where things start to get weird. Sperry and Gazzaniga probed the patient's hemispheres individually by stimulating the opposite side of the body, for example, by presenting an image to the right eye to stimulate the left hemisphere. In one early experiment, they flashed a series of lights across the patient's field of view. When asked to report when they had seen a light, the patients only responded seeing lights flashing on the right. But when asked to point whenever they saw a light, they successfully reported seeing lights on both sides. Next, Sperry and Gazzaniga projected the word heart, such that the letters HE appeared in the patient's left-hand field of vision and ART in the right-hand field of vision. When asked to report what they saw, patients verbally responded art, but when asked to point to the word they saw using their left hand, they pointed to he. Similarly, if an object was placed in the patient's right hand, they were easily able to name it, though when asked to point to an image of the same item using their right hand, they were unable to do so. When the sides were reversed, the patients could easily point to the object, but much to their confusion, they were unable to name it. This and similar experiments confirmed that language processing abilities are almost entirely localized in the left hemisphere, while the right hemisphere specializes in visual perception tasks such as recognizing faces and emotions and spotting differences between objects. But as strange as these discrepancies are, the experience of living with a split brain can sometimes be even more bizarre, with patients feeling as though they literally have two separate brains which are often at odds with one another. For example, patients have reported doing up their shirt buttons with one hand only to have the other hand spontaneously unbutton them, or placing items in the shopping cart with one hand only for the other to place them back on the shelf. Many patients are even able to copy 2 different images using each of their hands, though given the right hemisphere's greater spatial reasoning capabilities, the left hand is generally superior at this task than the right. In rare cases, this phenomenon can even take the form of alien hand syndrome, in which a patient's hand appears to have a mind of its own and sometimes attempts to strangle its owner or others. This is also known sometimes as Dr. Strangelove syndrome, after Peter Sellers' character in the 1964 Stanley Kubrick film, who exhibits similar symptoms. Unfortunately, there's no cure for the condition other than keeping the offending hand occupied with other tasks and restraining it at night to prevent injuries. In his seminal 1974 paper summarizing his findings, which would eventually win him the 1981 Nobel Prize in Physiology and Medicine, Sperry concluded, "Each hemisphere is indeed a conscious system in its own right, perceiving, thinking, remembering, reasoning, willing, and emoting, all at a characteristically human level, and both the left and the right hemisphere may be conscious simultaneously in different, even in mutually conflicting mental experiences that run along in parallel." Specifically, Sperry concluded that the left hemisphere specializes in logic, sequencing, linear thinking, mathematics, hard facts, and thinking in words. By contrast, the right hemisphere handles softer tasks like imagination, holistic thinking, intuition, visual spatial processing, facial recognition, and interpreting nonverbal social cues. Indeed, according to Sperry's experiments, the lateralization of mathematical thinking was almost complete. Tests for mathematical performance in the minor hemisphere with nonverbal readout and with the sensory input restricted to the left visual field or the left hand indicates that the capacity for calculation on the minor side is almost negligible. By manipulating marbles or dowel sticks, watching spots of light flash to the left field and pointing with the left hand, split-brain patients may succeed in matching numbers or in adding 1 to numbers below 10, but they fail when required to add or subtract 2 or higher numbers, and they fail also at the simplest tasks in multiplication and division. Later, Sperry observed the fact that the right hemisphere could in fact perform addition to sums of less than 20, the only exception to the left hemisphere's total dominance over mathematical thought. Later observations seem to confirm Sperry's findings, with neurologists concluding that primary achycolia, the fundamental inability to comprehend and perform mathematics, results only from damage to the left parietal region of the brain. By contrast, secondary achycolia, caused by damage to the right hemisphere, affects the brain's ability to retrieve mathematical information through the senses or express it through language, but is not its fundamental ability to comprehend and process said information. Less invasive studies further confirmed the task lateralization of the brain. In 1973, doctors Robert Ornstein and David Galen of the Langley Porter Neuropsychiatric Institute in San Francisco had test subjects perform a variety of cognitive tasks while an electroencephalogram, or EEG, monitored the activity in each of their hemispheres. When asked to perform mental arithmetic, think about writing a letter, or perform language exercises like thinking up a list of verbs beginning with the letters R, the subject's left hemispheres produced the fast brainwaves characteristic of attention and activity, while their right hemispheres produced low-frequency alpha waves characteristic of relaxation, indicating that that hemisphere was largely switched off during those tasks. When, however, the subjects were asked to produce designs using colored blocks, remember sequence of musical notes, or draw with an Etch-a-Sketch, the reverse occurred, with the right hemisphere producing fast waves and the left hemisphere alpha waves. As Ornstein and Galen concluded, our opinion is that in most ordinary activities, we simply alternate between cognitive modes rather than integrating them. These modes complement each other, but do not readily substitute for each other. But while Roger Sperry cautioned that experimentally observed polarity in right-left cognitive style is an idea in general with which it is very easy to run wild. But it was already too late. In a 1973 New York Times Magazine article discussing Ornstein and Galen's experiments, the two scientists stated that in different people, one hemisphere or the other dominates, shaping their innate talents and abilities. Ideally, we should be able to turn on the appropriate hemisphere and turn off the other whenever the task requires it. But in fact, we cannot always do it. Many persons are dominated by one mode or the other. They either have difficulty in dealing with crafts and body movements or difficulty with language. Culture apparently has a lot to do with this. Children from poor black neighborhoods generally learn to use their right hemisphere more than the left. They outscore whites on tests of pattern recognition from incomplete figures, for instance, but tend to do badly at verbal tasks. Other children who have learned to verbalize everything find this approach a hindrance when it comes to copying a tennis serve or learning a dance step. Analyzing these movements verbally just slows them down and interferes with direct learning through the right hemisphere. We don't have the flexibility we could have, says Ornstein. We are under the illusion of having more control than we really do. Early in life, it seems many of us become shaped either as left hemisphere types who function in a largely verbal world, or as right hemisphere types who rely more on non-verbal means of expression. These are two basically different approaches to the world. Further, the article stated that when the habit of always using the same side of the brain becomes too pronounced, it can narrow one's personality, Drs. Ornstein and Galen believe. The two researchers are currently working on a test that may enable them to tell which half-brain a person chronically favors and whether this habit interferes with the ability to shift dominance to the other side when necessary. They plan to try it out on people who are really specialized, like Ralph Nader, the left hemisphere type who has no hobbies of any kind, and right hemisphere potters, dancers, and sculptors, preferably people who have trouble with language. They expect to find significant differences between the two groups. This should give them a tool with which to guide children or adults to new aspects of themselves, to open them to a full range of experiences. Thus, a persistent pop psychology myth was born, with all manner of publications including Time Magazine, Harvard Business Review, and Psychology Today soon jumping on the left brain, right brain bandwagon. The theory was further popularized by Betty Edwards' 1979 book, Drawing on the Right Side of the Brain, in which the author presents various techniques for bypassing the analytical left hemisphere and allowing visual creativity to flourish. Today, left brain, right brain theory has spawned an entire industry of online quizzes, seminars, and other material aimed at helping people determine which side of their brain is dominant, get the most out of their natural abilities, or even strengthen the non-dominant side of their brains. This notion has even found its way into the world of business, where some companies try to hire right-brained employees for more creative roles and left-brained employees for managerial positions. But as is so often the case with the human mind, things are nowhere near as clear-cut as pop psychology would have us believe. For while the findings of Sperry, Gazanaga, Ornstein, and Galen seem to indicate that the right hemisphere plays absolutely no role in mathematical thinking and language processing, this is not in fact the case. Indeed, Sperry and Gazaniga observed multiple instances of the right hemisphere playing an active role in supposedly left hemispheric tasks. For example, one patient, when presented with a picture of his girlfriend in his left eye, was unable to speak her name, but was able to spell it out using Scrabble tiles. They also discovered that while the left hemisphere excels at making straightforward word associations, the right hemisphere is better at recognizing subtler relationships and insinuations. For example, when the left hemisphere was presented with the word foot, it was better at picking out a related term like heel from a list of words, but when the right hemisphere was presented with two additional words, cry and glass, it more easily picked out the connecting word, in this case cut. The right hemisphere also plays a larger than expected role in mathematical thinking, as Dr. Kara Ferdemeyer, professor of psychology at the University of Illinois, explains, quoting, "One problem with answering this question is that we would first have to agree on what logical and creative even mean. So let's consider a relatively more well-defined case. Math skills, which are often taken to be part of what the logical left hemisphere would be good at. There are different kinds of math skill, ranging from being able to estimate which of two sets of things has a greater number of items, to counting, to various types of calculations. Research shows that overall, the abilities that make up math skills arise from processing that takes place in both hemispheres, especially the brain area in each hemisphere that is known as the interparietal sulcus, and that damage to either hemisphere can cause difficulties with math. A left hemisphere advantage from math is mostly seen for tasks like counting and reciting multiplication tables, which rely heavily on memorized verbal information, thus not exactly what we think of as logical. And there are right hemisphere advantages on some math-related tasks as well, especially estimating the quantity of a set of objects. This kind of pattern, in which both hemispheres of the brain make critical contributions, holds for most types of cognitive skills. It takes two hemispheres to be logical or to be creative. Indeed, according to the popular conception of the left/right brain divide, we would expect people suffering from right hemisphere brain damage to become emotionless, but hyper-rational calculating and decision-making machines are rather like the Vulcans from Star Trek. In reality, however, such individuals struggle to make even basic decisions or plans as they lack the intuitive and emotional facilities to conceptualize the bigger picture and turn logic into practical action. Thus, logic and emotion do not, as is often assumed, stand in opposition to one another. Both are needed to effectively function in the world. Recent research has revealed that many cognitive functions are actually shared evenly between both hemispheres, including processing of visual and auditory stimuli, spatial manipulation, facial recognition, artistic ability, numerical estimation, and comparison. Even the left lateralization of core language abilities, as established by Broca, Vanitsky, and others, doesn't always hold true. For example, while Broca and Vanitsky's areas are usually located in the left hemisphere, in 5% of right-handers and 30% of left-handers, whose dominant hand, remember, is controlled by the the opposite hemisphere, they are instead located in the right hemisphere. Indeed, the lateralization of different cognitive functions varies so widely between individuals that neurosurgeons often perform a special test to pinpoint these cognitive loci prior to performing invasive brain surgery like removing tumors. Known as the intracarotid sodium amybarbital procedure or Wada-Mullner test, this involves injecting a barbiturate sedative into one hemisphere or the other to disable it and asking the patient to perform various cognitive tasks. The popular conception of brain lateralization also fails to account for the phenomenon of neuroplasticity, the brain's remarkable ability to adapt to physical change. Children who have had one entire hemisphere of their brains removed due to cancer or other disorders have gone on to live completely normal lives with the brain rewiring itself to perform all its necessary functions using just one hemisphere. Such neuroplasticity has also been observed in adults who have undergone similar surgeries or suffered traumatic brain injuries, though to a lesser extent. Okay, so the brain is more complicated than pop culture would have us think, and its functions more evenly distributed than we would expect. But surely different people favor one side of their brains over another, right? After all, how else can we account for some people being more logical and analytical while others are more creative and artistic? Well, unfortunately, science doesn't bear out that notion either. A 2013 survey carried out by Jared Nielsen and colleagues at the University of Utah analyzed the neural activity of 1,011 individuals aged between 7 and 29 while they performed various cognitive tasks in a resting state functional connectivity magnetic resonance imaging, or MSFC-MMRI machine. The study found that 9 left and 11 right lateralized hubs were identified as significantly lateralized connections. The left lateralized hubs included regions from the default mode network, whereas the right lateralized hubs included regions from the attention-controlled network. Left and right lateralized hubs formed two separable networks of mutually lateralized regions. Connections involving only left or right lateralized hubs showed positive correlation across subjects, but only for connections sharing a node. Lateralization of brain connections appears to be a local rather than global property of brain networks, and our data are not consistent with a whole brain phenotype of greater left-brained or greater right-brain network strength across individuals. Small increases in lateralization with age were seen, but no differences in gender were observed. We also found that lateralized connections are independent from one another across individuals, and that the majority of functional lateralization occurs before age 7. In other words, while localization of various cognitive functions does vary among individuals, on the whole, neither the left or the right hemisphere dominates in any significant way. Indeed, many skills and talents derive not from one hemisphere working more than the other, but from both working together more efficiently. For example, children considered gifted in mathematics or music tend to show greater communication between their two hemispheres, allowing them to more effectively combine both their logical/analytical and creative/intuitive faculties. Conversely, those who struggle at certain tasks do so not necessarily because one hemisphere of their brain is weaker, but often because one hemisphere developed to perform a task usually handled by the other. However, as with nearly all cognitive tasks, even the weakest skills can gradually be strengthened through practice. Yet, despite more than 5 decades of research debunking it, it is estimated that more than 68% of people still believe in the left brain/right brain myth. But why? Well, that's simple. Because we humans love to think about ourselves and come up with various systems to sort ourselves and others into neat categories, like horoscopes and personality tests. Quizzes for determining left or right brainedness exploit a psychological phenomenon known as the Barnum or Forer effect, the tendency of people to believe descriptions of themselves that seem personally tailored to them, which are in fact vague enough to apply to everyone. This effect, commonly used by astrologers, mediums, mind readers, and other hucksters, was most famously demonstrated by stage magician and paranormal debunker James Randi, who handed out personalized horoscopes to a classroom of students and asked them to rate the accuracy of the descriptions. Almost without exception, the students rated the horoscopes as highly accurate. Randi then asked the students to exchange horoscopes, revealing that they all had received the exact same one. The left brain/right brain fallacy validates and provides a seemingly rational explanation to our everyday observations that some people seem more logical and analytical and others more creative and intuitive. It also allows us to excuse and downplay our deficiencies. It's not my fault I'm bad at math. You see, I was just born right-brained. In reality, however, our cognitive skills and abilities are affected by a whole host of factors, including genetics, upbringing, mindset, and training and education, none of which can be neatly boiled down to simply being right-brained or left-brained. But while lateralization of cognitive functions may not significantly influence our personalities or innate skills, it nonetheless has a profound effect on how the brain functions. For example, while the information received and processed by each hemisphere is typically shared with the other via the corpus callosum, this can't always happen. As Dr. Kara Federmeyer explains, processing within each hemisphere relies on a rich, dense network of connections. The corpus callosum that connects the hemisphere is big for a fiber tract, but it is tiny compared to the network of connections within each hemisphere. Physically, then, it doesn't seem feasible for the hemispheres to fully share information or to operate in a fully unified fashion. Moreover, in a lot of cases, keeping things separate is literally the smarter way for the hemispheres to function. Dividing up tasks and allowing the hemispheres to work semi-independently and take different approaches to the same problem seems to be a good strategy for the brain. One of my favorite findings came from an experiment in which we used adjectives to change the meaning of the same noun. For example, the word book in Green Book refers to something concrete, that is, something for which it is easy to create a mental image. However, given interesting book, people now usually think about the content of the book rather than its physical form, so the same word has become more abstract in meaning. We wanted to see if those differences could be found for exactly the same word depending on what it was referring to and whether the two hemispheres were similarly affected by concreteness. We found in this experiment that the left hemisphere is very sensitive to the predictability of word combinations. Fewer nouns can go with green than with interesting, and the brain activity elicited in response to book reflected this when the words were presented initially to the left hemisphere. However, to our surprise, it was the right hemisphere that elicited imagery related to brain activity to Green Book compared to Interesting Book. Thus, although the left hemisphere is clearly important for language processing, the right hemisphere may play a special role in creating the rich sensory experience that often accompanies language comprehension, and that makes reading such a pleasure. In other words, even in those of us with an intact corpus callosum, our brain can sometimes behave like two independent entities, just like Roger Sperry's split-brain patients. Even stranger, until relatively recently in human history, this condition of having two minds may have been literally true. In his 1976 book, The Origin of Consciousness and the Breakdown of the Bicameral Mind, Yale psychologist Julian Jaynes argues that up until the Bronze Age, around 3,000 years ago, humans did not possess a unified conscious mind. Rather, the two hemispheres acted as separate, independent entities, with the master left hemisphere coming up with ideas and speaking them to the servant right hemisphere, which obeyed and carried out its commands. According to Jaynes, this bicameral mentality accounts for the ancient conception of ideas and inspiration as originating from muses or gods. As people would have been unaware that these thoughts were coming from inside their own brains, they would have experienced them as auditory hallucinations whose origins they would have then ascribed to an outside, typically supernatural source. This experience would have been similar to those suffering from schizophrenia, in whom internally generated thoughts are manifested as auditory hallucinations. Indeed, schizophrenia, along with autism and many mood disorders, including depression and bipolar, are associated with significant changes in the asymmetry of connective functions. For example, the left hemisphere is more associated with positive emotions and the right hemisphere with negative emotions. And those with depression often suffer from an excess of left versus right hemisphere activity. Schizophrenia, by contrast, is associated with a reduced asymmetry in activity between the two hemispheres. Jaynes' theory does not, however, imply that human brains were once physically divided. The neurology of the ancients was identical to our own corpus callosum and all. Rather, the mental schema of the ancients allowed them to react to situations, generate thoughts, and perform actions without the introspective ability to reflect on said thoughts and realize their internal origin. In other words, humans lacked a meta-consciousness or ego. This schema, Jaynes argued, was a product of the simpler communal living conditions of ancient humans, which did not require an introspective, unified mind to operate in. Only when people started living in more complex societies like city-states and began developing writing did the two halves of the mind merge to create the integrated, self-reflective consciousness that we know and love today. Taking James's theory one step further, British psychiatrist and philosopher Ian McGilchrist posits that the unification and lateralization of the brain has gone too far in one direction, much to the detriment of modern Western society. In his 2009 book, The Master and His Emissary, The Divided Brain and the Making of the Western World, McGilchrist argues that not only do the two hemispheres function differently, they also conceive of the world in different ways and promote different sets of ethics and values. The left hemisphere, for example, tends to reduce complex, nuanced subjects like ethics to simple rules and measures, while the right hemisphere is better able to view the world holistically in terms of interconnected systems. According to McGilchrist, Western civilization since ancient Greece has been increasingly dominated by left hemisphered thought, which promotes a narrow, reductive view of the universe, which has led to many of our modern global problems. But while highly influential and popular, James's and McGilchrist's ideas have also attracted a great deal of criticism, with many neurologists, philosophers, and historians arguing that, like the pop psychological notion of people being right or left-brained, these theories overly simplify and distort the more complex and subtle realities of brain lateralization and are based on shaky historical evidence. Whatever the case, what is certain is that, to paraphrase Scottish biologist JBS Haldane, the human brain is not only queerer than we suppose, but likely queerer than we can suppose.